Now we prepare for our paper 2, and this is our first session, looking at 3 sections. Organic alone is 3 topics. Then we have rate, which can be either 1 or 2 questions. And then we look at galvanic cell, half of the redox part. So without wasting much time, I need us to just start. Okay. Oh, and I'm starting with a multiple choice. Which one of the following pairs of compound belong to the same homologous series? It's important to be able to define what a homologous series is. It's a series of organic compounds that have the same general formula, the same functional group, and are separated by a CH2. Very important. They are separated by CH2. They have the same general formula. You can start throwing in your answers. All right. They have the same general formula. They have the same functional group and are separated by a CH2. So for me in this case, I would just quickly look at the formulas and find out which one has the same general formula. I have C2H6 and I have C4H12. Could that be an alkane? 2 times 2 would give me 4, plus 2 would give me 6. 4 times 2 on the other side would give me 8, plus 2 would give me 10. That is not a correct answer. So A is incorrect. What about B? I see that 3 times 2 would give me 6. And on the other hand, 5 times 2 would give me 10, but I need to subtract 2. Wrong. What about the next one is automatically wrong because I have 1 oxygen and I have 2 oxygen atoms on the other side. This is looking interesting. What about D? What could D be the possible answer? Please check. Let's check. Have I made a mistake? Could D, because I've cancelled A, B, and C now. So could D be a possible answer? C2H2, let's multiply 2 by 2. 2 times 2 would give us 4 minus 2. Oh, yes, that gives me 2. 3 times 2, 6 minus 2, all right, would then give me 4. Okay. Fat wrap. Isn't it A? Guys, let's discuss this. It's not A. Fatima, is that you or C2H6 and C4H12? They are not in the same because the formulas are not the same. If you multiply through, you would see a difference in the formulas. All right. I want to know if we are okay here. This is CnH2n plus 2. 2 times 2 would give me 4, plus 2 would give me 6. All right? Good. And this one here doesn't even exist. That doesn't even exist. So the correct answer, Lesejo, your mic is on. All right. The correct answer is D. And let's check if D is the correct answer. We have C2H2 and C3H4. That's correct. CnH2n minus 2 would work for both of them. So homologous series must have the same general formula. Do you want to tell me if this is an alkane, an alkene, or an alkyne? Quickly. CnH2n minus 2. Let's revise. Alkane, it's an alkyne. All right. Important. It is an you know how we revise, right? We just keep going on and on over different sections. So this is the correct one, and they are alkynes. Which one of the following compound is an isomer of CH3? This is interesting. I love this. CH3, CH2. Guys, What is this compound? Quickly, what is this? To which homologous series does it belong? Alkanes, alkenes, alkynes, haloalkanes, alcohols, aldehydes, carboxylic acid, esters, ketones. Where does it belong? All right, I have two answers. I have the third one, carboxylic acids. Lovely. And if you've been following my classes, you would automatically know that when it comes to this isomer here, this is a carboxylic acid. You should know automatically that we are talking about functional isomer. That's what comes to mind first. I'm sure you remember the cake. For those of you that have been working with me, cake. We said for every function, there should be a cake. For every function, there should be a cake, which tells me about functional isomers. And if it's a cake, carboxylic acid, you got to smile, guys, when you have a cake. You've got to smile. A cake would automatically bring a smile. Check that. A cake would bring a smile. Okay. A cake would just naturally bring a smile. Carboxylic acid would go with esters. Aldehydes would go with ketones. Carboxylic acid would go with esters. And aldehyde will go with ketones. But let's see. Could it be? Maybe they actually want a positional isomer. We don't know, but let's check. I see Nonkuleko says A. Let's go count. There are 3 carbon atoms. Okay, Nonkuleko might be right. Oh, no. Yeah. So we're talking about an ester. She's actually correct. That's an ester there. All right, so this is a carboxylic acid. It's a carboxylic acid. I'm just going to write an acid. And we know that for a carboxylic acid, it is esters. Let's quickly revisit something here. Please give me the name of this carboxylic acid and give me the name of the ester. Give me the name. We're revising, guys. Give me the name of the carboxylic acid and give me the name of the ester. All right, I see propanoic acid. What about the ester? I'm interested in the ester. I have a methyl ethanoate, which is correct. Which is correct. Is there anyone in the house who is not sure about how to name an ester? Because we just want to pass through quickly. Anyone not sure about how to name an ester? Let me know. Right, I have 2 people quickly. And this is how you name an ester. All right, I'm going to draw the same ester for us. And, okay, let me do this. We're going to name that ester fast. Okay, so we know that an ester is made from a carboxylic acid, all right? And what? An alcohol. No. Yes, an alcohol. And a carboxylic acid would give me an ester. So it is alcohol, we say ACE, plus carboxylic acid would give me what? Ester and water in the presence of concentrated sulfuric acid. Now, what do? We cut the oxygen. All right? The oxygen is where these guys combine. So I'm going to split it there. That's the point of where they are combined. I'm going to split it. Let's make it bigger. I'm going to split it there. I know know something about my carboxylic acids? My carboxylic acids have a double bond. Alcohols have a single bond. So you would immediately see that this is where my carboxylic acid comes from, because that's where the double bond is. All right, and this side is the alcohol side. Alcohol. Oh, and it is one. We always start from the alcohol. Start from the alcohol. So what will it be? Methyl. And there are two there. If you remember the organoclock, all right, 2 is eth. So ethanoate. I hope we are okay right now. I hope it makes sense, guys. And this happens in the presence of concentrated sulfuric acid, which acts as a catalyst because of its dehydrating ability. Are we okay now? Those of you that said you had problem naming an ester, that's how to name the ester. Cut the oxygen, cut the whole thing at the oxygen. Identify the two sides, one carboxylic and one alcohol, and then you name. End of story. You just count. Hope we are good to go. Forward. Number 3. The hydrogenation. Oh, wait. They have mentioned the word hydro. That's the first thing that I see. They have mentioned the word hydrogenation. What type of a reaction is that? Somebody wants to talk to me? They have given me the word hydrogenation. Let's quickly stop there. What is it? It's an... All right. Thank you. It's an addition reaction. And if you remember our addition acronym, SSS, USA, SUE, we are referring to an addition reaction, which is this. So the unsaturated would go to a saturated. Look, during the process, what's the correct answer? The number of double bond increases. No, it cannot increase because we are moving from unsaturated. We are actually moving from multiple bonds, let me write it here. Addition, we are moving from multiple to single. I see somebody has already given me an answer. All right, I see 2 people, or 3 rather, giving me the correct answer, which is C. The number of double bonds will decrease. And that's it. From unsaturated, we move to saturated. I hope these first 3 questions are okay in terms of you comprehending what I was saying. All right, we're done with organic there quickly. Consider the following reversible reactions. You have CO plus H2O plus CO2 plus that. And we are told it is endo. Please, very important, greater than 0, endothermic. The temperature is now lowered. Look, guys, before you even go and look at option A, B, C, D, you might be confused. Let's quickly analyze. We want to answer it first and then go and look for our answer. CO2 plus H2. This is greater than 0. It is endothermic. Okay. Now the examiner says the temperature is lowered. One thing I know is this, that an increase in temperature will always favor the endothermic. An increase in temperature. Don't forget the statement. An increase in temperature will always favor the endo. Now, if we are given this whole reaction, you see, I'm not even looking at the multiple choice yet. I'm just trying to quickly see, what do I understand here? It means, guys, the top here is endo. That's what it means because of that. Enthalpy is greater than 0. Oh, it means the reverse would be what? Exo. So if we lower temperature, what happens? Which reaction would be favored? Increase in temperature will always favor the endo. But if we lower temperature, which one is favored? Exo is favored. Okay, now let's go see what the examiner wants. All right, let's go see what the examiner, because we've simply analyzed, but let's go check what the examiner wants. The temperature is now lowered. Which one of the following statements is correct? The rate of the forward reaction is increased. That is wrong. That is completely wrong. Okay? That is wrong. The rate of both forward and reverse reaction decreases. That's very interesting, though. That's very interesting. Will both reaction decrease? If we lower the temperature, will both decrease? Sophie, you're laughing. The rate of the forward and no, that's wrong as well. Should that be wrong? Which one is favored, guys? Our reverse reaction should be favored. That's one thing we know. Let's write something here. We know that reverse should be favored. Okay, what does that mean when we say reverse should be favored? Let's check. What does that mean when we say reverse should be favored? It means that we should have an arrow that looks like this. Okay. But let's check something. Guys, I want you to take note of the language. I see a language here that the examiner is using. Please watch this. The examiner is using the word rate. Very key and very confusing, very misleading. The rate. They are not actually talking about the reaction that is favored or not. They are talking about the rate. My correct answer will be B. Because the examiner, I'm going to clarify, just give me a minute. We know that the reverse reaction is favored. Please follow through. The reverse is favored, right? But examiner is not referring to the reaction. They are referring to the rate. Why am I picking B? At low temperature, what happens? This is actually rate of reaction. Particles will have what? Low kinetic energy. So take note, examiner is talking about the rate, the speed of reaction. At low temperature, particles would have low kinetic energy. Therefore, the rate of reaction, whether it is forward or reverse, rate of reaction will decrease. This is not chemical equilibrium, by the way. I also was misled until I read the options. The examiner says the rate. But it's very misleading because it looked like chemical equilibrium, but it is talking about the rate of reaction. So at low temperature, particles will have low kinetic energy, hence the rate of reaction decrease. Very, very interesting. All right. Very interesting. Makes sense, right? So please take note. Let's read carefully. It says the rate. Rate simply tells you we're dealing with rate of reaction, not chemical equilibrium. Although they have similar factors that affect them, but the fact that they mentioned rate. But I'm glad we're able to quickly revise chemical equilibrium just in some few seconds there. All right, so do we all agree? Are we okay? Yes, I also thought it was chemical equilibrium until I saw the options saying rate. Very interesting. And this has actually taught us not to assume what the examiner is saying. We read through. Okay, 1.5. Hydrogen gas is produced in the reaction between hydrochloric acid and magnesium. All right? Which one of the following graphs of volume versus time best represent the formation of hydrogen gas until the reactants are used up? Again, this is rate of reaction now. What would your answer be? 1.5. What would you choose? What would you choose? This is rate of reaction. Which one of the following volume versus time best represents the formation of hydrogen gas? Awesome. Thank you for your lovely answers. We look ready. The correct answer is C, because at the beginning we have a 0. The gas is formed, it says, until the reactants are used up. All right. Until the reactants are used up. Beautiful. 1.6. The addition of a catalyst to a reversible reaction increases. Interesting. What's your answer? A catalyst. Now, this is talking about equilibrium. Okay. This is talking about equilibrium. The addition of a catalyst. Will it increase the equilibrium constant? Will it increase the products produced at equilibrium? Will it increase the rate of both the forward and the reverse? The rate of the forward only. All right, it is C again. Thank you, FETRAP. The rate of both reactions, chemical equilibrium is not affected by catalyst. That is why it is not listed as a factor. It affects both the forward and the reverse reaction. KC would stay the same. Interesting. I love this. Here we go. Let's run. Now we've come into the structured questions. It's going to get beautiful tonight. I feel it. Study the organic compound. Guys, this is what I like to do. It takes a few seconds. Now, your reading time, this is what I need you to do. 10 minutes reading time is to glance through this table. Question number 2. You are not allowed to write. Please don't be moving around all the pages. You don't have time for that. Question number 2. You look at the table and quickly identify the homologous series. You cannot write, but quickly identify. Once the exam starts, you will write what you have said. Propanal. What can you tell me? Which homologous series does that belong to? Propanal. Thank you so much. Thank you, Nonko. Thank you. Aldehyde. Now, you don't need a pen to do that. What about B?
Ketones.
Lovely. Ketones. Oh, guys, you look ready. Can we write tomorrow? Can we just write tomorrow? You guys look ready. What about C? Lovely. Esters. You guys, I'm requesting for tomorrow morning, 9 o'clock, be at school. The paper will be there waiting for you. What about D? Alkanes. Guys, I'm enjoying myself. Alkanes. What about E?
Carboxylic acid.
Ooh. Carboxylic acids. And what about F?
Ethene.
Huh?
Ethene.
Is it ethene?
In.
E-N-E.
Yes.
Okay, so it's an alkene and it is ethene. Lovely. Okay, let's go back now. You see, guys, you don't need a pen to do that. Do you understand my 10 minutes? Now, quickly, give me the name of B. It's not a train smash. It's a ketone. What the name for B? It's a ketone. What is the name for B?
U2O.
Huh? Nonku? Hi, Nonku.
I'll say build
It-
one.
Build on. You're wrong, though, guys.
U3O.
No, it's not 3. It's 2. But there's something wrong with what you're saying. And I see that. Yes. And Nonku said that, and I see that she also wrote that. Rabi and Fatima, you are wrong. It's not butanone. All right? It's not butanone. You must tell us where the carbonyl group is sitting on. All right. You must tell us where that is, and that is on carbon number 2. What is wrong with what Nonku told me? Nonku, this is what's wrong. You see, after alkanes, and alkyne, you must always add AN. It's butane 2-on, or what you can say 2-butanone. Please take note. After alkanes, and alkynes, with the rest, you must add the AN. All right? Fatima and Rabia, you must add the 2 for me. I hope everybody's okay. Do you want to give me the name of C? C is an ester. Give me the name for C. The ester. What did you say, Mduduzi? Good. There's one carbon on the left and there's one on the right. It's both meth. So it is methyl methanoate. We did how to name just a while ago. Please, if you are not so confident about anything I say, please bring me back. Remember, it's one session for organic. The other session, we need to cover the rest of the stuff. What about D?
Butane.
Huh?
Butane.
What? What you guys saying? D? Butane. Okay. Now you're talking from your nose. Butane. That's the easiest one, right? CH4. What about E? 1, 2, 3, 4, 5, 6.
Butanoic acid.
All right. Butanoic acid. You guys are on fire. Let's go right tonight. And F has already been answered. Ethene. Guys, you would see how we are going to move now. Look, your 10 minutes, you should have done that. Name the homologous series to which the following belongs. Do you notice we've answered the first 2? I'm going to skip. The first 2 has been done. A is an aldehyde. B is a ketone. Write down the IUPAC name of the alcohol needed for the preparation of C. C is methyl methanoate. What alcohol do we need?
Methyl 1-al.
Okay, it's just methanol because there's only one carbon atom there. Methanol plus, let's write the whole thing. We're revising, so we just go through. Methanoic acid. All right. But what we need basically is methanol. I hope everybody's okay there. It's methanol. Wait, guys, I want to ask you 2 questions here. All right. I want to ask you 2 questions. How do you know that an ester is formed? Katie Bonnie, you want to say something? How do you... Yes?
By a distinct smell.
Okay, not just a distinct, a pleasant one, a distinct, pleasant smell. All right. So don't just say distinct. There are so many kinds of distinct smells, eh? There is a distinct, unpleasant smell, if you know what I mean. All right. So it must be pleasant. Okay. I expected Sophie to laugh, and she did. When I said distinct, unpleasant. She's so predictable. Nonku, talk to me. Nonku Leko? Child. Okay. All right. Second question is this. When doing this experiment, one main precaution should be taken into consideration. What is that precaution? One main precaution should be taken. Sophie says we should use a water bath. Why? Thank you. Water bath, okay. Not open. You're still not giving me why, though. You're still repeating that. Because alcohol is highly flammable. You would go kaboom, boom. Okay, beautiful. Write down the letter that represents a carboxylic acid. I think we're done. That's E. Now, do you understand your 10 minutes, guys? It's not the time to pray. Pray before then. Okay. Polymers. All right. Although polymers, I think polymers are scratched. But we'll answer this question, guys. I don't know if you guys did polymer. Polymers are organic compounds with a wide range of applications in everyday life. Define an addition polymer. All right. I'm sure you have your exam guidelines. You'd get all the definitions. But a polymer is formed from a monomer. Is that okay? So a polymer is an organic compound that is formed from small unit monomers. Okay. Polymers are, it should be out, but I'll still talk about it. It's in the question paper. All right. I think there are. I'm not sure. But I think there are as regards 2021. But doesn't matter, guys. There's nothing much to talk about when it comes to polymers. Polymers are just large organic compounds from simple unit monomers. That's all. Okay. All right. Not in KZN. No, it's national. But anyway, let's move on. Polymers are large organic compounds formed from simple monomers or small unit monomers. Write down the letter that represents a monomer. It is F. And that's the only one they will always ask you, though, at your level. This is used to form polyethylene. And polyethylene is used in plastic bags, the one from ShopRite. It's called polyethylene bags. It's used in making squeeze bottles, some toy cars, also used in making bulletproof. Quite a range number of uses. Okay. These ones are fighting there. All right, guys. Give the structural formula of they said, please, it's in capital letter. Don't think they made a mistake by pressing cap locks. No. Give the structural formula for the functional group of A. Compound A. What is compound A? It's an aldehyde. What is the functional? So 2.5. I'll give you 30 seconds to answer that so that you can mark. Aldehyde. What is the functional group? You have 20 seconds more. You should be done. The difference between that and ketones is this is on the outside. That's what the examiner wants you to draw. Okay? That's what they want you to draw. I hope everybody's okay. Please let me know. So please go through your functional group table. It's the key to understanding organic chemistry. Give the general formula for the homologous series to which F belongs. What is F again? It's an alkyne. Do you want to give me that one? Because that you should be able to answer. Alkynes, the general formula of alkynes. Somebody talk to more. Oh, sorry, it's an alkene. I'm sorry. It's an alkene. So I'm sorry. It's an alkene. What is the general formula? Apologies. Okay, but we'll talk about the three. Alkane, alkene, alkyne. So it's CnH2n plus 2. This is actually a series, an arithmetic series. Common difference of 2. All right, beautiful. Use molecular form. Is compound D saturated or unsaturated? Let's go for compound D. Compound D, is it saturated or unsaturated?
Saturated.
Thank you, Sophie. Oh, I see answers are popping in. Good. Saturated. Come on, guys. I see my distinctions coming through. 2.8. Use molecular formula to write down a balanced chemical reaction for the combustion of D. For the combustion of D. Sophie, you remember the class we had in bronchosprate?
Yes, sir.
Good. The combustion of D. Do you remember all of that? Remember that crazy moment we had? All right. So what do we have? C4H10 plus O2, guys. This will always give you what? Carbon dioxide plus water. Now that is 2 marks. 1, 2. Everyone, please balance. Balance it. Balance that. Sorry, Mtutuzi, you were not in that class. It was far, far away in Kuvuki land. Quickly balance it and give me your coefficients of balancing. Give me your coefficients of balancing.
So can I give you?
Yes.
It's 2.
Yep.
13.
2.
13.
Uh-huh.
8.
Uh-huh.
10.
And what?
10.
Okay, do we agree with that? Anybody agrees? Are you guys? Oh, Sophie, you know what's happening? These guys are balancing the way they normally balance their stuff. That's why they're taking long. They're balancing the way they used to balance in grade 8, counting all of those. Guys, there's a secret of balancing this particular reaction. It's a little secret that allows you to balance in 7. Here comes my child, Nonku. Sophie, do you want to quickly share? Talk to them quickly. Okay, Sophie, I'm going to be your scribe. Sophie, I'm going to be your scribe. You are going to lead. Yo, no, uncle. Okay, so it's C4, H10, right? Plus O2 to give us what? CO2. And, all right, Sophie, what should we do? She said we should put 2 there.
Good. Now you multiply the 2 and the number after the C.
All right, which is 2 times 4.
Yes, the answer that you get, put it in front of the carbon dioxide.
All right, so 2 times 4 is 8.
Good. Now the last number, you see the number after H?
Yes, the number after the 8, which is 10.
Yes, put it next in front of the water.
We copy and we paste it, right?
Yes.
Yep.
Now multiply 2 and 8.
Multiply 2 and 8. That will give us what? 16.
Yes. Then add 10
Add it to this 10.
divided by 2.
Or we divide that by 2.
Now the answer that you get, put it next to oxygen.
And that's it, guys. That's it. That's it. I'm glad she remembers every little step. So, guys, but don't go and do all reactions like this. It's just for this one. Okay. Look, if we try this one, C5H10 plus O2, you know your maths. I balanced this in how many seconds? 7 seconds, if I remember. And they timed me. Put a 2 there. 2 times 5 would give me 10. The next number is a 10. Copy and paste. Multiply 10 times 2, 20. Plus 10. That will give me what? 30. Right? 30 divided by 2 would give me what? 15. Oh, no, yeah. And it's balanced here. Okay? Although I didn't use an alkane, I used an alkene, but it works across. If I were to use an alkene, C5H12 plus O2, watch this, plus H2O. The same principle, put a 2 there. 2 times 5, 10. What's the next number? 12. Copy and paste it. 10 times 2, 20. Plus 12 would give us what? 32. Divide that by 2. You get 16. But in this case, you would notice these are even numbers all through. We divide by 2. So I'll have C5H12 plus 8O2 to give me what? 5CO2 plus 6H2O. And that's it, guys. Yes? Just pick any alkane. Pick any alkane and try it. Just any alkane. C2H what? 6 plus O2. Balance that quickly. Try it. You have 10 seconds. No, you don't have to. Okay, Sophie? No, you don't have to write balanced behind it. Just balance it. It's fine. You don't have to write the word balance, B-A-L. You should be almost done now. You should all be done. We need to move forward. You should be done. Put a 2 there. 2 times 2 would give me 4. Write your answer there. Next number is a 6. Copy and paste. Put it there. 4 times 2, 8. Plus 6, 14. Divided by 2, 7. Done. Next topic. Thank you. That's it. Thank you, Fat Rap. So, guys, we're good. It was just a little trick there that we're using. Oh, we're done with this question, actually. Beautiful. Guys, I hope it's okay. I am going to try to, when we meet for tomorrow, when we meet during the next session, before I start that session, I'm going to look for complex structures for us to name. Okay? I need us to get the 1,2 dibromo tri and all of those in place. Is that okay? Yes, that's the whole idea. It was so quick. All right, thanks, my assistant teacher. Thank you very much. All right, question number 3 has to do with properties. Is that okay? Physical and chemical, physical properties. Look, let me give you a crash course on this before I look at the question. I always like to do that. Makes my life easy because I will have answered everything. We are basically looking at boiling point and melting point. Boiling point, melting point, and vapor pressure. I'm predicting that you will be asked to define vapor pressure in your paper. You will be asked to define vapor pressure. So please, guys, go and learn your definitions for boiling point and vapor pressure. But emphasis, boiling point and vapor pressure. Please just make sure you get through the definitions. It's in your exam guideline. Even if I say it right now, it will not help you. You need to write it. Okay. All right. Second thing is, what are the factors that affect boiling point? And, or before I go to that, what is the relationship between boiling point and vapor pressure? They are not inversely proportional. I'm going to write that with a different ink. They are not inversely proportional, please. If they are inversely proportional, then we can calculate. But they are not inversely. So, they are not, Sophie. When you say something is inversely proportional, it means there is a constant of proportionality that we can create. And we cannot create a constant of proportionality here. All we need to do is to say that when substances with high boiling point will have low vapor pressure. It doesn't mean they are inversely proportional. If something is inversely proportional, then it's mathematical. But this one, we cannot create a formula for it. So please take note. I hope it makes sense. When one increases, the other one, but they are not inversely proportional. It's just like, look at, if I tell you 2 and 3, 4 and 9, 6 and 12, 8 and 20, would you say they are directly proportional? Because as one is increasing, the other one is also increasing. Is this directly proportional? No. It is not. Because there is no constant of proportionality between these two numbers. If you notice, this one keeps increasing by 2. This one increases by 6 here. Then it increases by 3. So you see, I don't know if you get what I'm trying to say. That is what we mean by proportionality. If there is no constant value of increase or decrease, then we cannot use the word proportional. So they are not inversely. But as one increases, the other one decreases. I hope you got it right. You would have lost a mark by saying they are inversely proportional. Now, what are the factors that affect boiling point and vapor pressure? Number one is the chain length. And guys, when we talk about chain length, we are going to be referring to the same homologous series. Please take note. Once you mention chain length, you are talking about the same homologous series. You cannot compare alkanes and alkenes using chain length. Is that okay? You cannot compare alkanes and alkenes using chain length. Once I say chain length, it must be all alkanes. It must be all alkenes. It must be all alkynes. Is that okay? And what can we say here? The longer, just want to write my final answer here. The longer the chain, what are we going to say? The stronger the intermolecular force. I'm going to write in that exam. The stronger the IMF, all right, or let me say the stronger the net intermolecular force, because of more contact. All right, the stronger the longer the chain, the stronger the net intermolecular what? Force. Is that okay? All right, I see you guys are on fire. You're giving me all the factors already. Beautiful. I love it. I just love it. The longer the chain, the stronger the net intermolecular force, because there is more contact. All right. And you can also say that, let me put this on a fresh page so that it makes sense. So, what we will then say is that side chain hydrocarbons, all right? Side chain hydrocarbons, if I write HC, I hope you'll be fine. Have what? A lower boiling point than straight chain. Okay. Side chain hydrocarbon would have a lower boiling point than straight chain. Look, it's very simple. It's very simple. A guy with many side chicks would have low money in his account. Simple, end of story. I'm done. A man with many side chicks will have low money in his account. I hope that makes sense. Let's move to the next point. That's chain length. I hope you got that. The more side chains you have, the lesser the boiling point. Yeah, I'm done. I'm done. I dropped the mic. Boom. All right, what other factor were you guys giving me? Intermolecular forces. Okay. Intermolecular forces. And basically, you know we have three types of intermolecular force. All right. We have London. We have dipole, dipole. And we have what? Hydrogen. Look, it is important to just quickly know which ones fall under which. Is that okay? Here, actually all of them. But I'm going to write alkane. Just want to use this to explain something here. Alkene and alkyne. But it's basically all. Okay, I'll put in star all. The reason why we write alkanes, alkanes, alkynes only here is that when I get to dipole, dipole, then I'm going, okay, let me do hydrogen bond first. Hydrogen is what? Alcohols, which is one side, and carboxylic acids, which is what? Two sides. Now, the rest just comes in here. What do I have? Haloalkane, aldehyde, ketone, esters. What am I missing? Am I missing any other thing? Haloalkane, aldehyde, ketone, and esters. All right. Look, basically, let me explain what this table tells you. This table tells you that when I look at alloalkane has what? London and dipole-dipole. When I look at aldehyde, it has London and dipole-dipole. When I look at ketone, it has London and dipole-dipole. When I look at esters, it has London and dipole-dipole. When I look at alcohol on the right side, it has London dipole-dipole hydrogen. When I look at carboxylic acid, it has London dipole-dipole. I hope it makes sense. I hope it makes sense. I hope it makes sense. Are we good? All right, let's move on quickly. Let's move on quickly. All right, and you know how to respond to this, right? We use the ICE acronym to respond. You identify first. What do? You compare the strength. And number 3, you talk about the energy required. Okay. Now, this is the second factor. The third factor, which is not very common, Nonku mentioned that. She must have been following my teachings. The position of the functional group. All right. Now, if the functional group, I'm just going to say functional like this. If the functional group is on the terminal carbon, the boiling point or the melting point is high. On the terminal means carbon 1. All right. The boiling point is high. If the functional group is on the terminal carbon, then it is very high. Okay. And lastly, molecular mass. The bigger the molecular mass as well, and this actually, once the molecular mass is increasing, it means the chain length is also increasing. The higher the boiling point. And once I say the higher the boiling point, you should automatically know that the lower the vapor pressure. Let's answer these questions now, because we've summarized all of this. Let's answer the questions. I wanted to break this into 2. I hope it's okay, guys. Everybody's still okay? We need to ace this section as well. Okay, all right. Now it's very visible. Let me just do this one as well. Okay. Where are we? All right, a group of learners were investigating all right, Lionel, the position of the functional group. If the functional group is on the terminal, that is carbon 1, then the boiling point is high. Simply because we're saying that the functional group is exposed. That's the answer. This is why butane-1-ol will have a higher boiling point than butane-2-ol. Because if you check butane-1-ol and butane-2-ol, molecular size is the same, chain length is the same functional group, same everything. The difference is the position, where it is seated. All right. So butane-1-ol will have a higher boiling point than butane-2-ol. Because the hydrogen bond, which is very strong, is exposed. That's what we see first. That makes it strong. And butane-2-ol, they have practically the same thing, except they are positional isomers. So the one with the external position or terminal position of the functional group will have a higher boiling point. All right. Tandy, did you get what you wanted to get as well on the page? All right, let's answer this question here. A group of learners were investigating the intermolecular forces. Guys, quickly, you must understand now that we are then referring to our independent and dependent variables. All right, so intermolecular forces. Okay, as part of their research, they determined the boiling point of 8 different compounds represented by letters A to H. Okay, what can you tell me about ABC? Is there something you can tell me quickly about ABC? Because they've grouped them. What can you tell me about ABC? They are all alkanes. Beautiful. You guys are the best. These are all alkanes. And what is changing here? What is changing? They are all alkanes. I agree. What is changing? Which factor? We spoke about 4 things. The chain length. Oh, you guys are awesome. All right. What about B? What can you tell me about B? The second group, DEF. The second group, DEF. Aldehyde. They are all, lovely. I love your answer, Tamrian. Tamrian became more specific. They are all primary alcohols. Remember that a primary alcohol would have a higher boiling point than its secondary alcohol. Thank you, Tamrian, for bringing that up. They are all alcohols, but they are all primary what? Alcohols. So what is the difference? Why is their boiling point different? Since they are all primary alcohols, why is their boiling point different?
The chain length.
Good. The chain length again. Oh, so it's the same point here. What about G and H? What can you say about G and H? Is there something that we can say about G and H?
G is a carboxylic acid and H is an ester.
So what are we really testing there? Hydrogen bond? No.
The attachment is
Okay, not really. What are guys, we are looking at physical properties. What are we testing here? The first one you said chain length. The second one you said And what about the third one? Thank you, Nonkuleko. We are looking at, thank you, Lonel. I see your answer as well. Okay, Lonel, I don't want us to go functional isomers. I'm not sure, either Fatima or Rabia, but we are looking at intermolecular. You see, it's different functional groups. So this one refers to the intermolecular force, where this one is talking about hydrogen bond, and this one is talking about dipole-dipole. I'm sure pretty much that, guys, we have answered all the questions that follow. Give the structural formula for compound H. What is compound H? Ethyl ethanoate. I'm going to ask you to please quickly draw, because we are going to mark now. Draw, and you would mark yourself, but draw. Ethyl ethanoate. I'll give you 30 more seconds to draw. All right, we should be done. So you mark now when I draw mine. So the first thing we know is that it is an ester. So H, ethyl. Ethyl is how many carbon atoms? Finito. Awesome. How many carbon atoms? Eth. Eth o'clock. Nonku? Nonku.
Yes, sir.
How are you, my child?
I'm superb.
Ah, superb. Okay. So ethyl. She's superb. English. All right. And then I have that. And I have that. Please make sure you count the number of carbon atoms. Don't make a mistake. That's wrong now. And somebody's likely to do that. Please make sure when you finish, that's why you draw with a pencil. Okay? You draw with a pencil. And then you get it sorted. All right. Beautiful. So please make sure you always use a pencil to draw, and then check it out before you leave that question. Let's look at the next one. Explain why compound D and G have different boiling point. Explain why compound D and G have different boiling point, despite the fact that they have the same molecular force. In your explanation, refer to the molecular structure, intermolecular force, and the energy needed, D and G. Propanol and ethanoic acid. Despite the fact, what would your answer be? Despite the fact. I want someone to try. What would your answer be? Remember what they asked us to refer to? I need someone to talk to me. You don't have to type. Refer to the structure, the intermolecular force, and the energy needed. We are comparing D and G. I have already answered this question. It's a propanol and ethanoic acid. Use your ICE. Anybody talking to me? ICE. First identify according to the structure. You don't need to type. Anybody wants to talk to me, please?
So, ethanoic acid has
Go ahead.
I was going to say ethanoic acid has two sides of hydrogen bond, and propanol has one side of hydrogen bond.
All right. Okay, hold on, Nonku. Wait, Nonkuleko.
Molecular forces compared to propanol 1.
Okay, Nonkuleko, calm down. Wait. Yes. What was your first what was your first point again?
I said ethanoic acid has two sides of hydrogen bond.
Okay. All right, just a second. Just want to put your answer down. So we're looking at D and G, right? D and G. D and G. All right. D and G. What is our D? Which one is our D? Proper one all.
Yeah.
And which one is our G? Ethanoic acid. All right. So what did you say? Point 1.
I said ethanoic acid has two sides of hydrogen bond, and propanol has one side.
All right. One side of hydrogen bond. While this one has what? Two sides of hydrogen bond. All right, guys. Okay, let me do something before somebody does this. We write it in bullet forms, okay? So we can talk about the structure. Don't use a table. All right. D has what? D is our alcohol, like propanol, I think, right? One side of hydrogen bond. Let's make it very simple. Don't write too many things, guys. And H has what? Two sides of hydrogen bond. Okay, Nonku, go ahead. The second point is IMF, intermolecular. Yes.
H has strong intermolecular forces compared to D.
Lovely. Intermolecular forces. So H has what? A stronger intermolecular force. Than D. Okay. Lastly, we talk about the energy required. What do we say?
H requires a less amount of energy compared to D.
More energy is needed to overcome the intermolecular what? Force. All right. More energy is required. If you can write it like this, guys, you'll be fine. More energy is required to overcome the intermolecular force. In A than in D. Therefore, the boiling point, make your conclusion. The boiling point of H is higher than that of D. Guys, I hope it makes sense, please. Talk to me. I hope you are good with the structure and the pattern of answering the question. I need to hear from you. Let's move on. Yes?
We have to write the headings.
Do you have to?
Write the headings.
The headings. Not really. Not really. Okay, great. Now let's answer the next question. Compare A to C. Compound A to C have different boiling points, even though they belong to the same homologous series. Explain the reason for the difference in their boiling point. All right, we already answered that. We said chain length. Okay, but how do we write down our answer? I think how to write down the answer is actually more important. All right, from A to C, as chain length increases, all right, I like to use the word net. You could use it as well. The net intermolecular force, or you could say the net van der Waals force, all right? Or you can say the London force. But it's important that in this case, please mention that force. All right, either van der Waals, or you mention dispersion, or you mention London force increases. Say London in bracket. Please mention it. London force increases. So as the chain length increases, the net intermolecular force increases. Hence, the boiling point also does what? Increase. Hence, the answers are so predictable. Boiling point increases. These answers are completely predictable. All right. How will the vapor pressure of G compare to that of H? Do you want to answer that question? G and H. How will the vapor pressure of G compare to that of H? Sophie, just write. Okay, Nonkuleko.
The level of G will be lower than that of H.
All right, G will be lower than that of H. Beautiful. Sophie, you are correct, but instead of just saying CAB, just write it like that, from A to C, and save some time. Okay. All right, so we all agree it will be lower than. Lower than. Okay. Beautiful. It's lower than. Now, compound A and B are structural isomers. Define the term structural isomers. Definitions, guys. Definitions. Define the term structural isomers. What would you say? Yes, go ahead.
Organic molecules with same molecular formula but different structural formula.
Thank you so much. Organic compounds or molecules, right? What's the key word? With same molecular formula but different structural formulas. And in the same vein, I'm sure you can define the other types of isomers too. structural formula. And you know there are 3 different types of isomers, right? Chain, positional, and what? There's chain, positional, and functional. Lovely. Lovely. All right. I want us to be done here quickly. Name the type of structural isomers shown by compound A and B. Let's go back. Compound A and B. What type of... I think the answer is actually there. It's chain. All right. So guys, do you see that quickly spending some 3-4 minutes there to analyze your question actually helps? Just reading through, analyze. By the time you analyze, it's easy to answer your questions. Awesome. Everybody good with question 3? And just to mention, I'm sure that you have done questions here that require graphs, especially the definition of boiling point where the atmospheric pressure is equal to the vapor pressure. All right, there are a few questions on graph here and there, but not difficult as well. It's the same concept. Okay, let's look at the next one. This one I love. This I love. This I love. This is one of my favorites. SSS, SUE, and USA. If you know how to use that, you are good. All right. Now, let me quickly tell you something here, guys. Thank you. US, that's, and CEDS, don't forget. Okay? CEDS, just in case. CEDS. Okay, turn this way. Look, basically, if you remember your acronym, you would be fine. If you remember your acronym, that's the crash course I will do here. All right. SSS. Single and seriously searching. USA. That's where I traveled to. And I found my chocolate banana fruitcake salad called Susan. But I call her Sue Baby. All right. That's all you need. And CEDS. What does C stands for? Okay, so here we are saying saturated to saturated would be what? Substitution. Unsaturated to saturated, addition. Saturated to unsaturated, elimination. And this is proudly crazy physics. All of it, any way you see it. Proudly crazy physics. Okay. Katia, that's what it stands for. Sue Baby always kills. All right. So Bishop weds Sue, but I will not use the word weds. I will say Bishop said Sue. What does C stand for? Guys, when you use concentrated acid or base, concentrated acid or base, that's C, we are going to eliminate. And when we dilute, we are going to be substituting. Basically, dilute base. We will be substituting. Dilute strong base. I need to put this there. Dilute strong base. We will be substituting. So that's my CEDS. And when it comes to elimination, we need strong heat as well. And when it comes to substitution, we need mild heat. If you see my t-shirts that I made, you would see the fire there. I'm actually wearing one. at the moment with fire. All right. And this is the crash course you need. Now, let's answer the questions. This is what I need you to do for me, guys. When you see this question, look, the first thing you are going to count, guys, is the number of carbon atoms represented in this place. How many carbon atoms can you see here? Please look through. Look through. The number of carbon atoms will not change. All right? Except when you go to esterification. But generally, the number of carbon atoms remains the same, except when I go to esterification. All right? So the number of carbon atoms gives me an idea of what's going on.
Same way.
Look at the whole structure. There's something here. Don't look at an ester. This is an ester. Don't even go for esters. Don't go there. Look at here. You would find the number of carbon atoms. It's there. It's 4. Sophie, are you seeing that it's 4?
Yes, sir.
Okay. Thank you, Lonel. Lonel is actually saying, Sophie, it's 4. Look, automatically, once you see butane, I can tell you that. Straight. I can tell you that this is butane. We just need to find out where the 2-chloro is, and most likely it's going to be 2-butene. All right? And I can tell that this, because look, it's on carbon 2. I can already tell you that it is 2-butanol. It's a little trick. I don't even, yes?
Why listen to all?
Most likely. Do you see it's 2-chloro? This is the 2 that is giving me all the ideas that I'm getting.
Okay.
Is it making sense?
Yes.
That's the 2 that is giving me all the secret. Whoosh, science made easy here. Come on. All right. So I want us to study this without even going to look at the question. All right. Let's start. Where is reaction A? Do we have A? Because I just see, it's from B to H. All right. Guys, what do you think is happening between B? Look at B. This is saturated. This is also saturated. So what is reaction B?
Substitution.
Oh, it's a substitution thing. Sub. That's how we use the SSS, USA, and all those. Where is C? This is unsaturated, right? To C. Unsaturated to saturated. What would you say? We eliminate, right? Elimination. What about D? From saturated to unsaturated.
Elimination.
D. From saturated, the arrow is going up. Saturated to
Addition.
No. Okay, wait. We made a mistake here. C. From unsaturated to saturated. This one is addition, USA. And D, you were correct, elimination. Okay. Guys, I hope you've seen what I'm doing. Before I even answer the question. Where is E? Unsaturated to saturated. USE, elimination. I hope it makes sense. What about F? Saturated to unsaturated. It's the opposite. Addition. What
So
a...
E is addition, not elimination.
Oh, yeah.
Because you said USA.
It's USA. Addition and elimination. Thank you. What about G? This is saturated.
Addition.
All right. Guys, I hope it's making sense. Addition. Let's do one more thing. Okay, Loniel, I'm saying that it gives me an idea. All right, we're going to go back to the question now and check. But it gives me an idea that I could have but2 in and I could have but2 or butane 2 all. All right. I'm not saying that's the final answer yet. Okay. But it gives me an idea of where I'm going. Okay. Now, let's quickly check on something here. Let's go back to B. We are substituting. Okay. We are substituting. All right. We said we're substituting there. Or let's go to the question now and try to answer. I wanted us to do what I call stock taking. Stock taking. To see what are we really adding. Let me show you an example of what I mean by stock taking. This is an alkane. This is an alkane. Alkanes have 2 more hydrogens than alkenes. Remember, alkenes is double bond O. So I'm actually adding hydrogen. That's hydrogenation. Look at F. F is chloro. I am removing. And I don't just remove chloro. I must remove hydrochloro. So it's minus HCl. Dehydrohalogenation. If I look at alkene going to 2-chloro, stock taking, this is a butane. It's an alkane. This is a chlorine. So I'm adding HCl. Hydrohalogenation. That's what I call stock taking. All right. If you look at C, I need to add something to alkene to get an alcohol. I need to add water. If I'm eliminating butene, it has alcohol, all. All right. What do I remove to get an alkene? I need to remove water. So it's dehydration. I hope it's making sense, guys. I hope it makes sense. All right. Guys, leave my mic alone. What about H? What about H?
Esterification.
It's esterification. All right. Esterification. Do you want to tell me, look, this is butane 2-all already. All right? Like I'm saying, it might, but this one will not change. It's 2-chloro. Okay, we'll see. Because we need to form a primary alcohol. Remember what I said? I said the 2 is just tentative. Is that okay? So I'm going to put question mark. That we need to confirm by using our Markovnik curves and Zaitsev rule as we go on. All right. What carboxylic acid do I need here? Do you see this but? It's still here. That's my butyl. Now, what carboxylic acid do I need?
Propanoic acid.
Propanoic, because of this propane. So, propanoic acid. Okay. Remember, that we need to confirm, but it gives us an idea. Let's go answer the questions. Do you understand what I've done so far? It's just me playing around, guys. Just me having fun on this page. But I know that everything I do has to do with but. Okay. All right. Let's quickly answer now. Let's make it bigger. 15 marks. Are you aware that we have answered the first 2 questions? What type of reaction is represented in each of the following? Addition, substitution, or elimination? I'm going to pass because together we have answered all of that. We over-answered. What is D?
Okay, can you go back, like in the previous slide? Look at that one.
What is D? D is elimination. And, okay, so we've answered D, elimination. What about E? Addition. Right. Guys, do you see how fast it is by using your SAA, SSS, and all of those acronyms? 2-chlorobutane is converted into an alkene through reaction F. Okay, now this is what we're going to confirm. All right? 2-chlorobutane is converted into what? An alkene through reaction F. Write down the structural formula of the major product formed in this reaction. 2-chlorobutane is converted into an alkene. Let's go and check F. Oh, we are eliminating. And look, knowing how to draw is what makes sense here. 2-chlorobutane. Let me draw 2-chlorobutane. I'm sure everyone can draw 2-chlorobutane. It's a very simple structure. 1, 2, 3, 4. 2-chlorobutane. It means my chlorine is sitting there. It's a capital C and a cursive L. Okay, guys, we want to eliminate HCl because we want to form. Look, this is what I will tell you. I want to form an alkene, but my alkene must have 4 carbon atoms. What does it mean? It means the first thing that goes is this guy. Now, the question I'm going to ask, and this is where we're going to really do some work now. Which hydrogen will be lost?
Number 4. Number 4.
Number 4.
Yes, sir.
Why number 4 so far?
Because one says so.
Number 3.
It's actually number 3. Not 1, guys.
See how is it?
We take, now, there's what you call major and minor product. Okay. Major. So let's quickly do a crash course on this. We are removing. So the major product. So just take note of this. We remove hydrogen from the one less. All right? There's a word I want to put. We remove hydrogen from the one less to the adjacent. Okay, no. We remove hydrogen from the carbon. Let me write it well. We remove hydrogen from the carbon with lesser number of hydrogen. All right? Adjacent means next to the carbon that lost the halogen. I'm going to explain all of this big grammar now. So, we lost from here carbon 2. Carbon 1 and 3 are adjacent. Is that okay? But carbon 3 has less. The rich gets richer and the poor gets poorer. Zaitev's rule. All right. So please take note. The poor gets poorer. Zaitev. I hope it makes sense, guys. I hope it makes sense. So what are we going to have? C. All right. I want you to see something. We have removed that. So we have this. We have removed this as well. On which carbon atom? Oh, thank you. Nonku is telling me it's Zaitev. On which carbon? What's the formula here? What's the name of this compound? But2 in, right? Do you see, guys, that my 2 gave me an indication of what I should expect? I don't know if it makes sense. Do you see that too? I was correct from the beginning. All right. Reaction C. Let's write reaction C. What is reaction C? An alkene. Okay, this one, these 2 here, I'm checking. That 2 there, let's go. We need to confirm. Reaction C, alkene. All right? But let's check. But I think it's going to be correct. Alkene, our butene, it's an addition, guys. We want to form alcohol. Listen, should you not know what it's going to form? Look at what I'm going to do. So it's butene to give us an alcohol, right? Butene to give us an alcohol. Look, structures are the main thing here. So I am starting with butene. And I want to form an alcohol. Stock taking. I need to add something to that to give me an alcohol. Wait. An alcohol must have OH. Is that okay? An alcohol, where is that OH coming from? It must come. Remember we said it's an addition. It must come with water. Awesome. So, water. Please remember that water has to look like that. Okay. So what do we have? I'm going to draw the first compound that we have, but now it is going to be saturated. I like this structure because it's very symmetric. No matter where you add it, it will still be on carbon 2. Okay. But normally we add hydrogen to the one that has more carbon atom. All right. But this one is symmetrical. So even if you put it here, doesn't matter. It's symmetrical. It's still going to be carbon 2. What's the name? Boom. What did I write here, guys? I have my 2. Butane to all. Talk to me. This is the crazy way. Talk to me. Butane to all. Boom. Drop the mic. Boom. Everybody, are you okay? Are we still all right? Are we still all right? Oh, thank you, Fetrab. Okay. All good to pack. Thanks, Anae. Buduzi, how do you know that was Rabia? How do you know? All right, guys. Write down 2 conditions for the reaction B. Write down 2 conditions. Wait, let's go back. What is reaction B? Look, it is a substitution reaction. It is a substitution reaction. Guys, what are the conditions for substitution? My crash course. I don't know if you see your answer here. Look at what are the conditions for substitution reaction. Have you seen your answer? Dilute strong base. Dilute strong base and mild heat. CEDS. Dilute strong. I'll send you a picture of the t-shirts tonight when I'm done with class. It's not here. Okay. But guys, are we okay? Do you see that all the things have been answered? Everything you need is on this page. Literally on this page. So it's dilute, strong heat, dilute, strong base, and mild heat. Guys, so when you see something is substitution, it's not a serious thing, okay? Unlike elimination is very serious, you know? So question has been answered. I hope we are still good. I'll send you the picture. Reaction G is an addition reaction. Let's see if we got it right. Reaction G. Ooh, I hope we got it right. They said reaction G. Where is G? Oh, yeah, we got it. Do you see? We got it. We got it. We got it. IUPAC name of the alkane formed. Like, really? Question has been answered. What's the IUPAC name? It's a butane. Just by me seeing butane here, I know it's a butane. And it's an alkene, all right? An alkene, and I'm forming an alkane. What are we adding? Hydrogen, which gives me hydrogenation. Hydrogenation. Guys, I'm moving on. I hope it's okay. We're just having fun. Reaction H represents the reaction between alcohol. Guys, and we've already answered all of that. What is the IUPAC name of the carboxylic acid used? Somebody answered it. I didn't even answer. It's just propanoic acid. Name of the catalyst. Can you tell me the name of the catalyst here? I have mentioned it today.
Sulfuric acid.
Thank you. What type of sulfuric acid?
Strong.
Nana, sulfuric acid is already strong. What? You're Sophie, God of heaven. Where did I find this child? What type of sulfuric? What type of sulfuric acid? No, it has to be concentrated. Luniel? Guys, remember that esterification is an elimination reaction. We are eliminating water. All right? Esterification is actually dehydration. All right, let me just put it there for you. Esterification. All right. It is actually dehydration. So we need a concentrated sulfuric what? Acid. Don't forget your CEDS. Concentrated, eliminate, dilute, substitute. All right. Thank you, Loniel. I know you're good with that. The name of the process that takes place. Okay, guys, we're done. Rate of reaction. I hope it's okay, guys. Are we good? Can we move on to rate? So far, so good. Please, can I get your feedback? So far, so good. Two hours done. 2 hours gone. Has it been okay? You feel ready for this section that we've covered? So food. All right. Awesome. Let's look at rate of reaction. Now, you need a crash course here? Crash course? Rate of reaction.
Yes, sir.
Yes, sir. Okay. Rate of reaction. Crash course now begins. 5, 4, 3, 2, 1. Welcome to this crash course on Fetrav. You spoiled my radio show. Come on. You said boom, and it spoiled my radio show. All right. Welcome to this crash course quickly on rate of chemical reaction. This is DJ Bishop in the house from Crazy Physics. Good. I know Nonku is going to laugh now. She's already laughing. Rate of reaction. All right, look, the first thing I'm going to talk about is this one talks about speed. And we're talking about how fast or slow a reaction takes place. How fast or slow a reaction takes place. Now it's in Kaylee, it's in Bun. You know, it's just in me. All right. Now, guys, quickly, look, what do we need for a reaction to take place? What do we need for a reaction to take place? I'll write reaction like this, to take place. There are two things. Number one. No. Not reactants, guys. For a reaction to take place, particles must collide in the correct orientation. And number two, particles must have enough kinetic energy. When we say enough kinetic energy, energy greater than activation energy. Remember activation energy? The minimum energy required. So for a reaction to take place, particles must have enough kinetic energy, and what we simply mean is that the energy that they have must be greater than activation what? Energy. Thank you. Sufficient energy. And they must collide in the correct what? Orientation. Is that okay? Two people cannot back themselves and they say they are kissing each other. I mean, like, really now? How does that happen? Correct orientation. Okay. That's what, I hope the orientation makes sense. I know you like those kind of things. So everything we do here, guys, will be how to make these particles collide faster. How to make particles collide faster. This is what people call factors that affect rate of reaction. This is the simple thing we're discussing. All right? How to make... Tandy, particles don't just collide. There is a way they must collide. That's what we mean by orientation. All right? There is a way they must collide because there's a position for a reaction to take place. So particles don't just collide anyhow. All right? They must collide in a certain pattern and a certain way before a reaction can take place. Not all reactions are successful. Okay? Not all reactions are successful. Not all collisions are successfully what? Reactions. They must collide with enough energy and in the correct orientation. How to make particles collide faster? Number one, increase temperature. I see you guys already giving me answers there. Thank you so much. Number two, increase pressure if it's a gas. Number three, use a catalyst. Don't say increase catalyst, please. Catalyst cannot be increased. Number four, what do we say again? I'm reading your points. Increase surface area. Number five, what else do we increase?
Concentration.
Thank you, sweetie. Increase concentration. CPT. I see Fatrap gave me Cape Town. Increase concentration. And do you guys remember the sixth one? Lovely. The nature of reactants. Group 1 elements are more reactive than group 2, and group 2 more reactive than group 3. Beautiful. These are the 6 things that determine how fast particles will collide. Let me see. I need one more slide, I think. Now, let's talk about the word rate. Let's talk about word rate. If I want to talk about the word rate, time is involved. Okay. Time is involved. So, for me to talk about time, I'm going to talk about a fast reaction. What does a fast reaction mean? A fast reaction simply refers to high collision frequency. I'm using the word frequency now. If you remember the word frequency, frequency simply means number. A high collision what? Frequency. Frequency only means number. So what do I mean? I mean the number of collisions per unit time must be more. All right? Number of collisions per unit time. A high number of collisions per unit time. And that is what rate is actually all about. So a fast reaction talks about high collision frequency, the number of collisions per unit time. Good. Yes, Fetrab, you can also say effective. Our effective collisions actually comes from here. When is a collision set to be effective? A collision is set to be effective when particles collide in the correct orientation and they have enough kinetic energy. The more effective collisions you have, the faster the rate of reaction, because it's now a successful collision. All right. So how do we then define rate of reaction? The formula is this. It depends on the examiner, what the examiner wants. It depends on the examiner. This is moles per second. Depends on the examiner. Moles per dm cube per second. Dm cube second. Grams. So everything has to do with rate. So we can say it is the change in concentration of products or reactants per unit time. Per unit time. Okay. Lovely. Thank you, Sophie. And we answered a multiple choice question earlier on. What's happening? Quickly, if you look at, I'm going to draw 2 graphs, and I want to check something with you. What is the difference between the 2 graphs? This is time. What is the difference between the 2 graphs? Graph A, whatever you want to tell me with these labels, and graph B. What can you tell me about graph A and B? Yes, you may.
So graph B, so it starts at 0, and then it increases, and then at a certain point it reaches equilibrium.
Don't use the word equilibrium. Equilibrium only occurs when you have reversible reaction.
Okay, it becomes constant at a certain point.
Okay?
Am I right?
Yes, but that's not the answer I'm actually gunning for. The answer I'm gunning for is been set by Fat Rab and Umduduzi, but more with Fat Rab. Okay? Lionel as well. A talks about reactants because we are using them. So it is decreasing. It's a decreasing function. While B talks about products, we are forming. All right, so this is a reactant graph, and this is a product graph. I hope it makes sense. Because we are forming. And here we are using reactants. And we can always calculate our gradient. And here, what do we say? The end. This is the end of the reaction. Also here would be the end of the reaction. And you and I know that this is actually divided into 3. The reaction is fast here because of a steep gradient, steep slope. The reaction slows down because of a gentle slope, and reaction stops because basically no reaction there because of a zero slope. So take note of that. The same thing on the left-hand side. The steepness will tell us about the reaction. Let's go calculate. I hope there's a stoichiometry as well in this. I'm praying that there is a stoichiometry that we can look at. All right, a group of learners were investigating the factors affecting... Oh, by the way, let me just quickly say something, guys. These factors that we spoke about, all of these factors are independent variables. They are all independent variables. Take note. Because these are the factors we are changing. They are independent. Variables. Independent variables. Okay. All right, let's quickly answer questions now. I want to make sure we get this done. All right, a group of learners were investigating the factors affecting the reaction rate. In one of their reactions, sodium thiosulfate, which is a precipitate, all right, it forms a precipitate rather, and hydrochloric acid are reacted according to the balanced equation below. All right, you would see here, guys, always use the phases to guide you to what's happening. That's a solid there. So we are talking about a precipitate being formed. During the reaction, one of the products formed causes the solution to turn cloudy. Due to this, the mark X drawn on paper on which the reaction mixture is placed were not visible after the reaction is completed. Refer to the sketch. Okay, so this is what's happening. This is when we start the reaction. Now, because we are forming a solid, it becomes a precipitate. It blocks the X. So as you see, the X fades away as the reaction goes on. Here, the reaction has stopped. Completed. So that's the whole idea. All right, this is called precipitation reaction. Let's answer. All of those stories are fine. Now, in the investigation, the learners took sodium thiosulfate of different what? Concentration. Quickly take note. Different. That's one of the factors. Different concentrations. I can tell you that I've answered 5.2.1. Independent variable. All right. Yes, Sophie. Reaction rate is always the dependent. The time taken is the dependent. The independent is the conditions. I hope that, look, that's a free mark there for everyone. All right? Now, they said different concentration and reacted with HCl, hydrochloric acid of constant. Oh, so the hydrochloric acid is constant concentration. That is my controlled variable, the word constant. So it is the concentration of HCl. Don't just say HCl. It is the concentration of HCl. By the way, guys, temperature should also be kept constant here. So these are things that you could write as your constant because temperature will affect. So temperature could therefore be kept constant. Yes, Nonku, the reaction rate will become the dependent. How fast the reaction takes place. Independent is what you are changing. Is that okay? And what you are measuring is the dependent. You are measuring the time. Okay? All right. Let's see. Define the reaction rate. We've defined that already. We've answered our next question already as we were trying to interpret. I hope it's making sense. Nonku, are you okay? All right. So the independent variable is the concentration. Guys, don't just say concentration. It's concentration of sodium thiosulfate. We need to be specific. Write down the name or formula of the substance responsible for, I think I already answered that, for the cloudiness. I already answered that there. It's sulfur. That's why reading through the phases actually matters. Write down the name or formula, S or sulfur. Consider the table of results and write down which trial 1, 2, 3, 4 occurred at the highest reaction rate. Which one do you think happened at the highest reaction rate? Legodi says, why sulfur? Check there. It's a solid. Look at the faces. That's aqueous. That's solid. So when you form a solid, what happens? It's a precipitate. It is a precipitate. Are we okay? All right. Okay, guys, reaction 1. Was it the one that happened? Yes, because we only took 43 seconds. We only took 43 seconds. Draw a graph of concentration against time. In the attached graph sheet. I don't think I attached a graph. Did I attach a graph sheet? Let me check. No, I didn't. Oh, sorry, guys. But what will your graph look like? Your graph, all you need to do, your graph would look like this. This one is a free mark. They told you that concentration here and time here, okay? Because they said against time. Now, what's happening? Concentration is 0.15. So it's 0 here. You can use 0.03, then 0, if you keep adding 0, then that will be 0.09. It must be a good scale, guys. 0.15. And then here, let's see. It's 120. Let's see what we can use. No, 240. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I can use 30, 60, 90, 120, 150, 180, 210, 240. It must be a scale, guys. All right. 0.15 and 43. Okay, my graph. Yep.
I want to confirm something like you told me that the independent variable is always on the x-axis. Or here we're going with the instruction you gave us.
Actually, we should actually draw independent should be on the x. Okay? I should actually reverse this graph. Independent should be on the x. Okay? You are right. Independent is on the x because that's what we said, remember. The independent variable is our concentration. Okay, that's very important. I always use this. index. I think I spoke about this. Independent on the X. So here, I just read the instruction and I carried on. Concentration and time. That's a very good one there that I missed it. All right. Thank you, Nonku. Independent always on the X, index. And we said our independent variable is the concentration. What did I write earlier on? 0,03, 0,06, 0,09, 0,12, 0,15. And I had 30, 60, 90, 120, 150, 180, 210, and 240. Very good observation. Thank you very much. All right, what do we have? Just want to sketch this. Time is flying. 0,15 and 43. Somewhere there, 43. Okay, it's a sketch, guys. 0,09 and 66. 09 and 66, somewhere there. All right, 0,06 and 100. Somewhere there. And 0,03 and 240. All right. Please, it's not a straight line, guys. Join. Join the points. Join the point. Are we okay? All right. So, guys, okay, I see your argument here. No, time is not independent. Time is dependent. Time is what is measured. Okay, I hope we got that. Independent is what you are changing. And what we are changing here is the concentration. So concentration is on the X index. All right. Yes.
You know why you're saying time is the independent?
Because of the verses against time.
No. Because you're told that time does not depend on anything.
No. In this case, time is dependent on the factors.
Yeah, I understand that. I was just telling you why we're always saying time is independent.
Oh, okay. All right, but I hope it's clear to everyone now. Talk to me, everybody. I hope it's clear. That's a very lovely discussion there that I'm going through. But guys, are we okay? Is it confirmed that we are okay? Can we move on? Independent is on the X. And when it comes to rate of reaction, your factors are the independent variable. Great. Name two other factors. Name two other ways in which the rate of reaction can be increased. What do you want to tell me about 5.7? Two other ways. What can we do to increase the rate of the reaction here? What can we do? Increase temperature. Add a catalyst. Lovely. Increase temperature. Add a catalyst. Okay, don't go to, Modise, don't touch the concentration of the HCl. Let's leave that as constant. There must always be one constant. Okay? So the best answers are we add a catalyst and we increase temperature. We'll leave the constant variable. All right, 5.6. Use the graph to make a conclusion. What would you say? What would be your conclusion there? What would be your conclusion? The rate of reaction would increase, right? As the concentration of sodium thiosulfate increases. The rate of reaction would increase as the concentration of sodium thiosulfate increases. Yes, Mtutuzi. For this graph, the rate of reaction will always be your y, and the rate is basically your time. It will be your y-axis. And independent would be the factors. So all the factors would be the X. Are we good, guys? I have answered rate of reaction. I was hoping I'll get one with a stoichiometry. I need to look for it, though. I need to look for one with a stoichiometry where we have to calculate some things. Okay, let me see something. What's going on here? Something is cooking oil. Okay, yes. I actually wanted to talk about Maxwell Boltzmann's distribution. Okay, just a second. Oh. All right, just a second. I think I made a mess here. Okay. All right, guys, let's push quickly. I hope I'll be able to get to galvanic. What about this question? Guys, one of the steps in the preparation of sulfuric acid in the industry is that. Is this endo or exo? No, the graph paper is for another question. Fat trap. The graph paper is for another question. We're just going to answer this. I'm not going to write except when necessary. Exo or endo? Explain your answer. What is the answer here? Explanation.
Energy of the reactants determine the energy of the product.
Products have what? A lower energy. Energy of the reactant is?
Greater than the energy of the product.
Thank you. Energy of the reactant is greater than the energy of the product. Beautiful. Exo releases heat. Lovely. According to collision theory, give two conditions necessary for a reaction to take place. I think I did answer that already. Do you remember that? We answered that already, right? According to collision theory, give two conditions. We did mention those conditions earlier on during my crash course. Correct orientation, and particles must have enough kinetic what? Energy. That was a very good crash course there. Answers were predicted. Vanadium pentoxide is added to the catalyst in the above reaction. Explain how the presence of vanadium pentoxide as a catalyst affects the rate. Guys, how does catalyst affect the rate of reaction? You will be asked on Monday to define a catalyst. You will be asked on Monday to define a catalyst. Please check the definition. You will be asked to define a catalyst. And how does that happen? Thank you, Mduduzi. It lowers activation what? Energy hence creating an alternative pathway. Creating an alternative pathway for the reaction to take place. All right, or more particles will have enough kinetic energy. Let me quickly draw the Maxwell-Boltzmann distribution curve for that while we are here. Okay. All right, so this is what we have. Normal activation energy here. These are the particles that will react. But when I have a catalyst will reduce the activation energy and bring it backwards. So all of these particles, so this is EA of catalyst. All these particles will now react. All of these ones. So there are more particles. So this is how the Maxwell-Boltzmann distribution curve is represented. This is the amount of particles. and this is kinetic energy. I hope you know how to read that graph, guys. I hope you're not seeing it for the first time. I hope we're not seeing it for the first time. Are we okay? Not really. There are two types of catalysts. There is what you call positive and a inhibitor. Inhibitor is like a negative catalyst. It will slow down. A positive catalyst increases. A negative catalyst, which is called inhibitor, will slow down the rate of reaction. Some reactions are too fast to be studied, so we slow them down by using an inhibitor. But for at our level, we are only going to refer to a positive what? Catalyst. Okay. We okay, guys? Calculate the enthalpy. You know how to calculate enthalpy? What's your answer? Quickly calculate. Let me see your answers. Calculate enthalpy. What will it be? What is your enthalpy? Quickly. I'm answering 6.4 now. Enthalpy. Tamran, where are you lost? I know you had network problems. Where are you lost? All right, I'm seeing your answers. Beautiful. Negative 111. Correct. Tamron, tell me where you lost. Yeah, we're doing enthalpy with a graph. That's what we're doing. We're doing enthalpy with a graph. Our enthalpy is here. That's our enthalpy. So it's HPR minus HR, negative 86 minus 25. And that will give me negative 111 kilojoules per mole. Okay. No. You must calculate. You must calculate. You must calculate. All right, guys. Just to add to this question. Nyankuleko, you don't know how to read the Maxwell Boltzmann distribution. Okay, that's what I just explained. All right, so this is what you have. I'm going to guide you through again. This is what you have. That's your normal Maxwell Boltzmann. The particles that would react. You see, the particles that would react are particles that have energy above the activation energy. Okay? So only these particles will react because this is my EA. These ones, they have low kinetic energy, so there is no reaction here. But when I put in a catalyst, it will decrease my activation energy. Oh, instead of my EA to be here, my EA is brought back. Do you see now that more particles, all of these ones will now react because our activation energy has been decreased. Does that make sense now? That's how you read. Huh?
Thank you.
All right, that's how you read the one for a catalyst. Guys, can you please calculate what is the activation energy for this reaction? I want to check something with you. What is the activation energy for this reaction? EA for this reaction. For this reaction, what is our EA? Anybody wants to give me the value? I'm glad you guys did not say 68. Thank you very much. It is 68 minus 25. I was waiting, but thank you very much 43 kilojoules per mole. Now, this is for the forward reaction. Do you want to give me for the reverse? What is the one for the reverse? What is the EA for the reverse? EA for the reverse? $154. So if you don't just reverse the numbers. For the reverse, we start from here now. That's for the reverse. Is that okay? So it's 68 minus negative 86. And that will be 154 kilojoules per mole. All right, are we okay there? 6.5. Let's quickly answer that. What is the activated complex? It's not a common definition, but here we are. It's here already, so let's define it. It's an unstable state. An unstable, it's that situation where it's unstable. An unstable transition, I'll use that word. All right? Between the reactants and product. It's unstable. Between reactants and products. Okay, guys. All right, that is rate of reaction. I think I purposely put... okay, don't define it like the highest point. This is the correct definition. It's an unstable transition or an unstable state from reactants to product or between reactants and product. You are trying to explain, and the question says define. All right. Guys, I put this particular question simply because I saw that there is Maxwell-Boltzmann distribution. All right? And I'm only going to focus on... I think 4.1 is basically the same thing that we did a while ago, all right? So I am just going to answer 4.2 because of the Maxwell-Boltzmann. Already we've answered 4.1 in the previous question, so let's cut it out as we save time. Because I know that quite a lot of people are not exposed to the Maxwell-Boltzmann distribution. All right, below is the Maxwell-Boltzmann distribution curve of the distribution of kinetic energy of molecules at two different temperatures. Let me quickly check with you guys. Which one is a higher temperature? Is it A or B? Which graph? Which one is a higher temperature? Loniel says B, Fatrab says B, Lesedi says B. I'm glad you guys are on board. All right. Good. All right. Since you got that, I think I'm fine. Oh, Sophie says why B? Because the graph melted. Fetra, please don't kill me yet. Yeah. All right. Why B, Sophie? I'm going to explain to you using my highlighter. So this is what we have. Is that okay? These are the particles that have enough kinetic energy to react. When we increase the temperature, what happens? Particles then gain enough kinetic energy, all right, such that they begin to move from where they have low. More particles start flowing in terms of kinetic energy because the kinetic energy is increasing. It goes there. That's why the amount of particles decreases here because they are already flowing onto the right-hand side to where there is more energy over the EA. I don't know if it makes sense, Sophie. So this one is low temperature. this is high temperature? Because the particles here are already moving towards the side. They are distributed based on energy. Sophie, talk to me. And every other person who might seem lost. Check what we have again. All right. These are the ones that will react. Immediately I start heating this, increasing temperature. These particles here, or the ones closer here, start moving this way because their energies are increasing. So what happens? The graph will drop. More particles now have enough kinetic energy. All right, I hope you got that. Please, now, finally, it is important to know how to use collision theory to explain your rate of reaction. Please don't just say temperature increases, rate of reaction increases. Please, you'll be losing marks. Okay, Sophie said she still doesn't understand. All right, Sophie, let's do this. Sophie, I'm going to try to get you now. Check this. Let's check something in your school. All right, this is your school gate. Only people who have 7 rand would be able to go out of the school gate. That's my activation energy. All right. Now, there are a lot of kids that have 1 rand, 2 rand, 3, 4, 5. All right, I'm sure a lot of people have 3 rand, quite a number of people. Check, only a few people have above 7 rand. Okay. Now, what happens? Suddenly, the principal decides to give everybody 2 rand each. What do you think will happen? Remember, only people that have above 7 rand can go out. The principal decides to give everybody 2 rand. What do you notice? People who had 5 will now be able to go out. Is that okay? But people who have 1 still will not be able to go out. People who have 2. But the number of people in school now will be less, while the number of people out would be more, out of school. Talk to me. Does that make sense to you? Thank you. Good. So you have more people. If you have more people, what's happening to the graph here? It's decreasing now because less number of particles are now present here. Okay. Thank you, Lonel. When I say check this, something amazing is coming. All right, guys, quickly. In answering your questions, please remember, in answering your questions, you need to use collision theory to answer. What do I mean? 1, if I say there's an increase in temperature, what does that lead to? Increase in temperature would lead to what? Increase in kinetic energy. What happens? Collision frequency increases. And what happens? Rate of reaction. This is how your answers must flow. That's number 1. Number 2, increase in surface area. What would happen? More particles are available, or more particles are exposed. And if that happens, collision frequency increases, rate of reaction then increases. Number 3, if we increase concentration, what happens? There is more particles per unit volume. What happens after that? Collision frequency increases, rate of reaction increases. What happens if we increase pressure? All right, the distance between particles becomes shorter. When that happens, collision frequency increases, rate of reaction increases. 1, 2, 3, 4. All right. Catalyst we spoke about. Catalyst, what will happen in terms of catalyst? Activation energy is lowered, collision frequency increases, and rate of reaction increases. All right, guys, I hope this makes sense. So this is using your collision theory to explain. Okay, catalyst. What happens? Activation energy decreases, and collision frequency that. I don't know if this makes sense, guys. I don't know if this makes sense. Talk to me. Did it make sense? You would notice that the last 2 points are the same. The last 2 points are the same. It makes rands too. Guys, I've enjoyed myself tonight, honestly. I've totally enjoyed myself. I don't know if we are on the same page, but I totally enjoyed myself. I'm sure, guys, you can calculate this one now. This is doable now. I want the stoichiometry question. Define the rate of reaction. Use the table to sketch a graph. Calculate the rate of reaction at 240. Easy stuff, guys. We just measure 240 on the graph. All right, we just sketch the graph. Okay, here there's a graph page. Do I really need to sketch this one? No, don't worry. It's not more work, guys. It's not really more work. Just enjoying the flow. I'm just enjoying the flow. Is it a bad thing to enjoy the flow? No, guys, we have 15 minutes. I want to end at 10. We need to rest. Okay. Guys, I want to believe that you would be able to sketch this graph, but let's quickly see. All right. It says the data in the table below indicates the changes in volume of N2O5, all right, dinitrogen 5 oxide, recorded at different times. Use the graph page to draw a graph of the results. Use the attached, okay, at the end of the question paper. Now we have time and volume. Okay, guys, please, this one is not, volume is not a it's not a factor that affects rate of reaction. Okay? All right? Volume is not a factor. So this time around, get the dynamics. Time would come here. And volume would go there. Okay. How do we calibrate? 0, 100, there are 8 of them. Let's check what we have here. 1, 2, 3, 4, 5. Okay. That means, guys, I cannot use 100. So 200, 400, 600, 800. And that's 0. What about my volume? Let's see, 0,1 and then 0,019. How many do we have? How many do we have here? 1, 2, 3, 4, 5. So we can use 0,02, 0,04, 0,06. I hope 0,08. Let's see, 0,1. Do I have more than 0,1? All right, it's fine. Perfect. So all we need to do is to sketch this now, guys. The first one, 0 and 0,1. Okay, there we go. Number 2, 100 and 0,081. 100 is somewhere in the middle there, exactly half. 0,081. 082, 084, 086. I hope it's making sense. So 081 is somewhere there. So you can see your graph is decreasing. Okay, so this is what you do. 200 to 0,066. 200, 0,066, somewhere there. And it's not a straight line, guys. 300 and 0,054. 300 is somewhere there. 054. 04. This is 042, 046, 048. 054. No. 42. This is 5. 5 divided by 0,04. All right. 44448, 52. What am I looking for again? 54. All right. 54 should be the third one. I have my graph there. So you must know how to sketch. 400 to 0,044. 400 to 0,044, which is there. Exactly there. All right. 500 to 0,035. Guys, this you can then complete. All right. And then your graph comes that way. Okay. And then you finish up. That's how you sketch your graph. Just want to show you the last one. That's why I'm sketching the graph. Calculate the rate of reaction at T equals to 240. This is what you then do. You trace this graph. My aim was the last question. 240. This is 300 is there. 240 should be somewhere 200. Okay. Since I have 200 there, 200, that's 40. Okay, yeah. 240 is the first one. I'll trace it to the graph, guys. All right, this is not perfect. And then I calculate the change. So my rate of reaction would be the change in volume over the change in time. Okay. The change in volume over change in time. So 0, change in volume, 0,1 minus 0. It's just like you're looking for the gradient. All right? Not minus 0,6. And then 240 minus 0. Please note, I quickly want to say something here. Don't leave your answer as negative. Please. Here you are going to get a negative, but don't leave your answer as negative. Very important. 0,1 minus 0,6 over 240. Do not leave your answer. This is negative 20,08 times 10 to the power negative 3. Therefore, the rate of reaction, please, is 2,08 times 10 to the power negative 3 dm cube per second. Please don't leave your answer as negative. All right. Okay, guys. Yes?
Why did you subtract the 0,6 from 0,1?
Oh, it's 0,06. It's like I'm looking for gradient. I'm actually wrong. It's 0,06.
So, underneath you should also say 0 minus 240, right?
Let's see. If this is my V2 and this is V1, okay? All right, 0 minus 240. I know that my answer would be a negative. Okay. No, it will still be a negative. 0 minus 240, right? Guys, what's the answer here? But whatever we do, do not leave that answer as a negative. Okay. Don't leave that answer as a negative. 0,1, it's 0.6, I think. All right, over negative 240. We'll still have, all right, it's negative 1,6. Thank you. Thank you. Thank you, Fatrab. Negative 1,67 times 10 to the power negative 4. Negative 1,67. 1,67 times 10 to the power negative 4. Please just don't leave your answer as negative. It's volume, right? So it's dm cube per second. Okay. Positive. Positive. You know it's positive. 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 You know. Positive. All right. Guys, anybody challenged with galvanic cell? Anybody challenged with galvanic cell? Positive. Positive. Negative. Negative. Yes. You know, that's how we roll. Good. All right, let's see. Our teacher didn't even touch. Oh my God. Okay. All right. It means, okay, because I have people here who are saying that they didn't even do it at all. You want us to do a crash course? But okay, let's do this. Can we do the crash course in the next session then? So we are fresh. We'll start from here. Guys, I know you have an idea of chemical equilibrium, you have an idea of acid and base and all of that. So I suggest that if we're going to do a crash course, we do it when we are all fresh, and then we answer. It's not difficult. It's not difficult at all. What I will do is, when I get back into the office tonight, I will upload. But I think I thought I did upload some of the galvanic cell. But I will quickly see if I can upload them to you and send you a link. You can then go through tomorrow morning. Right now, rest. Tomorrow morning, you go through it before the class. So you have an idea so that the crash course you will not be overwhelmed. Yes, we'll then do. So we have 3 sections to do. The electrochemistry, chemical equilibrium, then acid and base. All right. So I will upload, and then it's easier to do a crash course when you have an idea of what's going on. Awesome. But it's been a good night so far, I believe. It's been a good night. I enjoyed the whole session. Did you enjoy like I did?